In the past decade, the focus of wastewater engineering has shifted from protecting human health and pollution control to sustainability and resource recovery. Resources like ammonia and phosphate are essential for human food supply. Since phosphorus is non-renewable, this opens up an opportunity for chemical engineers to resource valorization and optimization. A decentralized wastewater treatment system is developed, where nitrogen and phosphorus are extracted to produce fertilizers. This allows them to re-enter the crops and subsequently our diet. Unabsorbed nitrogen and phosphorus consumed will be excreted and removed to the sewage system, producing feedstock for the system, forming an infinite loop, making phosphorus a renewable resource. So, how does the system work? Firstly, a waterless sorting toilet is used to separate urine from feces. The urine collected is then transferred to a precipitation reactor. Here, the urine is mixed with calcium hydroxide where phosphorus is precipitated as mineral fertilizer crystals. The crystals are captured by a sieve bag, whereas the ammonia-enriched solution is pumped to the stripping columns. Air is used to extract ammonia from the solution while calcium hydroxide is added to maintain the pH at 11. The resulting solution is then treated as an effluent. The ammonia-rich air then travels to a scrubber unit, where sulfuric acid is added, to form an ammonium sulfate solution. This solution can be reused as a base fertilizer. Meanwhile, the effluent is then used to flush the human excreta from the toilet storage compartment into a flocculation tank. Here, additional calcium hydroxide is added to clump the colloids in the solution together. Afterward, the mixture is transferred to a settler, where the agglomerated particles sink, while the brown water floats. The brown water is then pumped into a reactor to undergo partial nitrification and anammox reactions to extract nitrogen as nitrogen gas. The phosphorus-rich solution is then sent to a precipitation reactor again, to extract the phosphorus. The resulting liquid is then sent to a tertiary water treatment unit so that it meets the discharge guidelines. Meanwhile, the sludge from the settler is transferred to an anaerobic digester where organic matter is broken down by microbes to produce methane biogas. That is fed into a combined heat and power unit to provide energy for the system. After digestion, the sludge is pumped to a pressing unit to reject water. Lastly, the biosolid produced is then mixed with a bulking agent and left for aerobic fermentation to produce compost. Moving on, the proposed system has some great features. 1. The use of waterless sorting toilet can save up at least 30 liters of water per person daily, which equates to 1 day drinking supply for 15 people. Secondly, partial nitrification is favorable as it can save 25% oxygen consumption, reduce 300% sludge production, and 20% carbon dioxide emission during denitrification. Lastly, the operation condition is mild and little to no waste is produced. Developing countries such as India is lacking proper sewage treatment, where only 8% of wastewater is being treated. The establishment of a wastewater treatment plant requires high capital and operational cost which is not feasible in these countries. Proper sanitation is a human's right, and our system is the solution, with the additional benefits of clean water and fertilizer production to support agriculture. With low flow rate, the size of units in the system is minimum. By fitting the system into a large shipping container, it can then be delivered to every part of the world. The system is inherently more sustainable with 96% reduced water usage. Lower aeration allows around 36% reduction in energy demand. Overall, the total operation cost decreases by up to 42%. Studies have shown that brown water treatment is actually energetically self-sustaining. While a theoretical economic assessment of the system suggested that 1 meter cube of urine generates a profit of 10 ringgit. Based on the human population of Malaysia alone, that equals to 16.5 million ringgit of profit annually, which can be used to sustain the system. It was reported that the amount of phosphorus in Dutch municipal wastewater corresponds to more than 50% of the artificial phosphorus fertilizer used in the country. Wastewater is no longer seen as a waste, but a resource which can be treated and utilized for other processes. Breaking the paradigm of treat and dispose, forming an infinity loop.